All right, lesson 9.4, day 2, geometric series. We did arithmetic yesterday, and we learned that a series is when you take a sequence and add up all the terms. Today we're going to do it with geometric. This is the last lesson of the semester, so that's exciting. So the learning target, I forgot to put a little target symbol here. Students will evaluate a finite geometric series. We also evaluate some infinite geometric series on the back. It has to be a special kind though to be able to do it. Okay, so if you think infinite, like how am I going to add up an infinite number of numbers? Well, there needs to be some special circumstances for that to work. So first off, let's derive the formula ourselves here. So this is written a little bit differently. Instead of G1, you can think of this as A1. We've been doing A1s. This is A1 all the way through. So the first term is A1. The second term, A sub 2 is actually A sub 1 times R. And then A sub 1 times R squared would be your A3 and so on. So that's why we're not adding the numbers up. We're not naming them by A1, A2, A3, A4. The terms, it's just how would you find the term? So if you wanted the third term, you'd have to multiply A sub 1 times R twice to find the third term. So think of these as A's. Now it says multiply S sub n by R. So I'm going to take R times S sub n. I'm going to take everything over here times R. So if I multiply this whole thing by R, I'm going to distribute an R out to every one of them. So this would be R times A sub 1 plus, actually I'm going to write this, but I'm going to say A sub 1 times R. I should have wrote A sub 1 times R. And then plus A sub 1 times R squared, R cubed, because it was R squared, I multiplied by R and got R squared. Do that for all of them, all the way up to the last one. When I have A sub 1, when I have R to the n minus 1, and then take it times R, that's one more R, so it's going to be R to the n. Okay, so if I multiply both sides by R, I get this, and then it says subtract the preceding equation. So I'm going to take the first equation minus the second equation. So I'm going to take S sub n minus R times S sub n. So if I take the top minus the bottom, well, A sub 1, there is no A sub 1 down here, so that doesn't get taken away. But A sub 1 times R, A sub 1 times R, they would wipe each other out. So my video froze here. There we go. So this is A sub 1 R, that's A sub 1, that cancels out. A sub 1 R squared, A sub 1 R squared, they cancel each other out. Over here is going to be one that's going to cancel that one out. All the way down to this would cancel the one before it out, but then that one's left over. So this would be plus A sub 1 times R to the n. Okay. Now looking at both sides, there's something that could be factored out of both sides. So on this one, I could factor out an S sub n, and that would leave 1 minus R. On this side, I could factor out an A sub 1, and that'd be a 1 plus R squared. I'm sorry, this would be minus, because this is like 0 minus this, so that'd be a minus. I'm sorry, I have that wrong there. So this would be a minus R squared. And let me get some white out for that. Okay, and now my goal was I want to find S sub n. I want to find out what's the formula for adding up the sum of a certain number of numbers. So if I divide both sides by 1 minus R, I've got S sub n equals A sub 1 times 1 minus R squared over 1 minus R. That happens to be the formula over here. So this isn't just some made-up formula. Like you can mathematically find this, and somebody, for the first person that found it, that's how they found it. They mathematically subtracted, simplified, and got this. And it works every time. Now, I did find one mistake on here. Actually, on yours does not have a 1. I found that mistake. So fix that right now. That should be a 1 right there on your notes that I gave you. It has an A there. And also, there should be a 1. So I think I was typing a little too fast whenever I made these notes. I was in a hurry. But if you want to find the sum of a finite geometric series, meaning there's a certain number of numbers, there's a locked-in number of terms that doesn't keep going on forever, and I want to add them all up, so A sub 1 all the way through A sub n. So if this was A sub 10, that means there's 10 terms. As long as R is not equal to 1. R equals to 1 is not in geometric anyway, because you would have your first term, and the second term would also be the first term. You'd just be adding up if the first term was 5, and you're going to multiply by 1, you'd have 5 plus 5 plus 5 plus 5. That's, you just multiply by the number of numbers if it's a finite series and get it. So this formula wouldn't work. But this formula, as long as r does not equal 1, this formula works. Where a sub 1 is the first term, r is a common ratio, and n is the number of terms. So let's look down here. These are all geometric. So I'm not trying to trick you. They're all geometric. We just got to figure out what are they. What's the r? What's the sum? So on this one, the number of terms, well, it stops. So 1, 2, 3, 4, 5, 6. There's 6 terms. What's the r on this one? Remember, anytime you want to find r, take any term divided by the previous term. 24 divided by 12, 12 divided by 6, 6 divided by 3. All those quotients are 2. Okay? So the sum of those numbers is going to be, the first term is 3, 1 minus 2 to the 6th power, all over 1 minus 2. When you put this in the calculator, make sure you use a lot of parentheses. Make sure the parentheses are on the top, parentheses are on the bottom, all that good stuff. And if you do it right, you should get 189. So I would definitely pause the video now and make sure you did that. You can do that. Make sure you can type that in the calculator, because there's really no point in going on if you can't put it in the calculator right. If you can find the right, plug it in right, but not get the right answer, then kind of wasting time. The next one here has a ... It says 10 terms, so the n is 10. What's that common ratio? Take any term divided by the previous term. So 5 divided by 15 is a third. 15 divided by 45 is a third. So your common ratio is 1/3. So my sum is going to be my first term, which is 135. And then 1 minus my ratio, which is 1/3. There's 10 numbers. I'm going to take 1/3 to the 10th power. And I'm not subtracting first. This isn't going to be 2/3 to the 10th power. This is 1 minus whatever a third to the 10th power is. So make sure you put in the calculator, you want to do a third to the 10th power first. And then divided by 1 minus 1/3. Okay, so practice, maybe pause the video here and practice putting that in. Make sure you can put that in the calculator correctly. And it's okay to have a weird decimal. So when you get a weird decimal in this, don't think you did something wrong. Okay, so if you did it right, and I'm rounding here, it keeps going. Okay, and the reason why it keeps going there is these numbers are getting smaller and smaller. Eventually they become some crazy decimals. You just keep dividing by 3 and you're going to get some irrational numbers eventually, and this thing is going to keep going. So we don't need to write them all the way out. In fact, I probably went a little too far on that one. But now the 100th term, and this one's going to be a weird one because it's alternating. So if I took 2 minus 4, it's -2, plus 8 is a +4, minus 16 is a -8. So like the sum, it's you'd think it'd grow pretty big, but it's not. The numbers are getting bigger, 2, 4, 8, 6, and it seems like it's going on and on and on. But it's not not going to be too much. So my number of terms is 100 terms. The common ratio, take any number. This one looks kind of weird, but take any number divided by the previous. So -4 divided by 2 is -2. I could also do -16 divided by 8, -2. Doesn't matter. I can find it pretty quick. So the sum of these 100 numbers, I really should be putting 100 in here. I'm sorry. 100, this should be a 10, and this should be a 6. So the sum of the 6, if we're being exact. So the first number was 2, 1 minus, and this is going to be -2 to the 100th power, and then 1 minus, and then -2. That's actually going to be in a plus. Okay, so put that in the calculator. Take a lot of parentheses here. So do a lot of parentheses. Okay, so do a lot of parentheses, and remember we said it looks like they're going to keep canceling each other out. But think about how much bigger is that 100th term than the 99th term, because we're doubling every time. So it seems like they're going to keep wiping each other out, but what we're figuring out is about how much bigger is the 100th term than the 99th term, because they alternate negatives and they double. So this one actually comes out to be a pretty big number. We thought they wouldn't happen because they kept canceling each other out, but they're deceiving sometimes. So -8.45 times 10 to the 29th power. That's a huge number. Okay, so be careful on those. I'm trying to mislead you there at the beginning. So they alternate. If it's finite, it could potentially be a pretty big number there. Especially when it gets to 100th term. Okay, the next one, the Smith family. Let's do an application. The Smith family, start saving for a vacation that is 1 year away. They start with $125. Each month they save 8% more than the previous month. So it's not like they put $125 in the bank and they're earning 8% interest. It's the next month they're going to save 8% more than $125. So you got $125 plus another $125 and a little bit more. So they'll have $250 with a little bit more on top by the end of the second month. So they're just going to keep saving more and more every month. How you would possibly keep that up, I don't know. How much money will they save? Will they have saved in 12 months? Well, first up, the A sub 1 is 125. So the first month, 125. And if they're going to save 8% more, I don't want to put an 8% here, or 0.08, because 0.08 means they're not. It's going to be losing. We're going to save that amount plus 8% more. So the growth rate here, or the common ratio, is 1.08. Okay. I'm sorry, this is supposed to be in the next page, but it got moved up here. So after 12 months, what I'm really trying to find is the sum of the first 12 months. So that's going to be, I'm going to take A sub 1, which is going to be 125, and then 1 minus the rate, 1.08, to the 12th power divided by 1 minus 1.08. Okay, so put that in the calculator. And this, so after a year, how much total they have saved. So we're adding up those 12 months. And it's going to be $2,372.14. So at the end, that's how much money they'll have saved. Okay, so it's a good vacation. Or they could wait a few more years and take a really big vacation. So they're thinking, maybe let's wait 4 years. So how many months would that be? That'd be 48. You could actually go back in your calculator and just change the 12 to a 48. Use that, I say copy and paste, but it's not really copy and paste. You just scroll up on your calculator and hit enter, and then you can go change the 12 to a 48 and hit enter again, and now it's 61,266.52. That's a good vacation there. I'm not sure what kind of vacation I would take with that kind of money. Okay, so if you flip your paper over, again, this is supposed to be on the back side, so for your notes, yours is on the back side for this. But we're going to talk about infinite series. So infinite series behave differently depending on what you're multiplying by. If you are multiplying by anything larger than 1, that thing is just going to keep growing. So if you have an infinite number of numbers, it'll never stop growing, and you can't find the sum. It's just a ridiculous amount of money, or amount of, whatever you're talking about. Amount of numbers. It's a weird way to say it. But if that is less than 1, you know, if your growth factor is less than 1, then you're eventually adding such a small amount that it's not really changing things, and you could add everything up. So what we call that, when it's not really adding much, is when the R value is less than, or the R value, the common ratio is less than 1. And I put the absolute value of that because if it was a negative 0.5, it's still decreasing the amount. You know, we kind of think we call that decay when we did exponential growth, called decay. So the next amount, you know, once you get to the 100th amount, you're not really adding very much, and then we can eventually add it all up. You know, because as you get to infinity, you're not adding anything, essentially. Okay, we call that a series converges. So it's convergent. So a series is going to converge. You know, con means with. So I think about it. If it converges, that means it has a sum. It's with a sum. You can do it. It does. If we were talking about limits, you know, if you graph this guy, it does approach a limit, so it's with a limit. So that's how I remember these two. Con means with, converge. So it's with a limit or with a sum. And then the other one, if it doesn't do that, if it just keeps going on forever, then it diverges. We call it divergent. But it diverges, approaches no limit. There's no sum, and that is when R is greater than 1, the absolute value of R. So if it's above 1, or if it's below -1, if I'm taking it times -2, it's going to keep getting bigger and bigger in the negative direction, and you're going to approach negative infinity, and there's no way to add it up. So the only way you can add it up is if your common ratio is less than 1. It can't equal 1. If it equals 1, it's not geometric in the first place. But so if R is less than 1, then we use a different formula, okay? So the sum of an infinite geometric series, where r, the absolute value of r is less than 1, is this guy right here. It's even simpler than the other one. So it's just a sub 1 divided by 1 minus r. So again, as long as you know the first term and the common ratio, you're good to go. There's not even an n this time. You know, on the front side, we had to worry about n. On the back side, we don't need to know that even, because it doesn't have an n. It's going to go forever. So decide whether each infinite geometric series diverges or converges, and then state whether the series has a sum. So maybe let's just do this right now. Fill these two columns out. So fill out the r value and the converge or diverge part just on your own to see if you can identify them. Okay, so I went ahead and did them all. Again, every r, just take the previous, you know, this term divided by the previous, that's a half. Here, every term divided by the previous. Yeah, same thing here, every term divided by the previous. This guy here, again, that's written in summation notation, so 2/3 is in the r place on that one. Now, what is the first term on these guys? Well, the first one's easy, it's 8. This one's easy, it's 1, and that one is 2. What about this guy? It's not really written, okay? So the first term is I need to plug the 1 in. Now, some of you may have thought that the first term is a 1 because there's a 1 out front here. That's only if it was written like this. That's the typical explicit formula for geometric. This isn't written as a typical. This has an n up here. So I need to really actually just plug 1 in. So 2/3 is actually the first term there. So try these out. So the sum of these infinite terms is going to be the first term divided by 1 minus the r. So I'm taking 8 divided by a half. I can do that in my head. I don't need a calculator for that, right? Some of these you don't need one. Some of these will, but some of these you don't really need a calculator for. The sum of these guys and the first term is 2/3, and then 1 minus, the first term, the common ratio is 2/3. So I got 2/3 divided by 1/3. What's 2/3 divided by 1/3? Well, what's 2 divided by 1? 2. So if I added all these terms up, the first term is 2/3, and then you're going to take 2/3 of that, and then take 2/3 of that. You're just going to keep, well, it only adds up to 2. It kind of seems weird to think about, but you could actually try it. Do the first 10 of them, you're getting close to 2. Okay, next guy. A sub 1 is 1 divided by, and then 1 minus negative 1/3. So that'd be plus 1/3. Divide that out, you get 0.75 or 3/4. And then this guy down here, well, what am I supposed to do? Well, I can't do it because it diverges. I can't find that sum. So the sum, I mean, this one, you look 2 plus 4 plus 8 plus 16 plus 32. I'm just going to keep adding huge numbers and huge numbers, so there really isn't one. Yeah, I'll put infinity down, but there's none. There is no sum for that. Okay, the last one, this is something that maybe seems kind of weird, but it's helpful if you ever have to convert a decimal to a fraction and you don't have a calculator and it's a repeating decimal. We can use this idea to make it a fraction. So if I want to know what is 5.1616, I'll just put this instead of rewriting it. And I actually made a mistake down here. It should be 161616, not 6161. If I want to find out what this is, well, first off, I'm going to split this into 5 plus. And think of this, instead of 0.161616, think of it as 0.16 plus 0.0016 plus 0.000016. And this is a geometric series now. So I'm going to think geometric series. I need to take the sum. I'm going to go from n equals 1 to infinity. And my first term, my a sub 1 is 0.16. And then my, what am I doing every time here? Okay, so every time, if you take any term divided by the previous, you get 0.01. So that's my r, my common ratio. So I got my a sub 1, my r, and that's all I need. So I got 5 plus, and I got 0.16 over 1 minus 0.01. That's going to be 5, if you get it on screen here, plus 0.16 divided by 0.99. Now 0.16 divided by 0.99, if I move the decimal over twice on those, that's just 5 and 16/99. If you type this in the calculator, take 16 divided by 99, you'll get 0.161616, and you find out pretty quick, what the fraction was.